Good morning, students. Today we are going to discuss the last topic from the second unit, that is kinematic equations of circular motion. The previous videos and all we have discussed about the kinematic equations, that is for uniformly accelerated motion, and here we are going to see the kinematic equations of circular motion. Let us see what are the kinematic equations we have learned for the uniformly accelerated motion. We know that we have learned these four equations. V is equal to U plus AT. S is equal to UT plus half AT square. Now, third equation is V square is equal to U square plus 2AS. And the last equation is S is equal to U plus V or V plus U divided by 2. So you can use S is equal to V plus U by 2 into T. So these are the four kinematic equations we have previously derived, and it is for linear motion, kinematic equation for the linear motion. Now we are going to write the kinematic equation for circular motion or angular motion. For that it is very simple. You just use, instead of this S displacement and all, S you use theta. This is for linear motion. When it comes for circular motion or angular motion, use the displacement S is, instead of S you use theta. Instead of V, final velocity, you use omega. This is what angular velocity. And instead of U, you use omega 0. And acceleration, you use alpha symbol. And this is what we are saying. Angular displacement, angular velocity. This is also angular velocity, and this is angular acceleration. These are the symbol we are using. Now by using this symbol, just we are writing this kinematic equation for circular motion. So V means omega. So first equation is V equal to U plus AT. How we can write in circular motion? So instead of V, you write omega equal to U means omega 0 plus alpha t. Instead of A, we are using alpha symbol, angular acceleration, then T as it is. Second equation, S is equal to UT plus half AT square. So instead of S, we are using theta. Then instead of U, we are using omega 0, then T plus half. Instead of A, we are using alpha T square. Second equation finished. Now the third equation, V square is equal to U square plus 2AS. So V square means, V means omega, so omega square equal to U square, omega 0 square plus 2AS. A means alpha, S means theta. So omega square is equal to omega 0 square plus 2 alpha theta. And the fourth equation is S is equal to V plus U into T by 2. So S means theta equal to V means omega 0 plus U means omega t by 2. So these are the four equations. Omega is equal to omega 0 plus alpha t, theta is equal to omega 0 t plus half alpha t square, omega square is equal to omega 0 square plus 2 alpha theta, theta is equal to omega 0 plus omega into t by 2. These are the four kinematic equations for angular motion, and it is one of the very important 2-mark questions. So my dear students, you have to learn this question. It is very important 2-mark, very simple 2-mark question. Okay. Now let us discuss the questions, book back questions. You can note it down. The first question is explain what is meant by Cartesian coordinate system. In page number 42 you can see that answer. So this part you can write at any given instant of time. The frame of reference with respect to is the position of the object is described in terms of position coordinate x, y, z is called a Cartesian coordinate system. Okay. So page number 42, question number 1. Short answer question in page number 42. Now I have shown that is a part. Now second question is define a vector, give example. In page number 46 you can see. So in page number 46, define a vector and what give examples. So it is a little difficult. So define a vector, give examples. Here you can see vector in page number 46. Vector means what? It is a quantity which is described by both magnitude and direction. Examples: force, velocity, displacement, position vector, acceleration, these all. So this is what question number 2 in page number 46. Then question number 3 is define a scalar, give example. In page number same 46 you can see scalar. It is a property which can be described only by magnitude and example: distance, mass, temperature, speed and energy. Now next question is write a short note on the scalar product between two vectors. So answer is in page number 53. So you can go through the page number 53. So here, so question is you have to write the short note on scalar product between two. So write a short note on the scalar product between two vectors. So here it is in page number 53. Definition: the scalar product of two vectors is defined as the product of the magnitude of both the vectors and the cosine angle between them. Then you have to write this formula: a dot b is equal to ab cos theta. That is what question number 4. Question number 5 is the same short note on vector product between two vectors. In page number 55 you can see the answer. In page number 55 the definition. So this definition you can write the vector product of two vector definition. Also this formula. So in page number 55 you can see the answer of question number 5. Now question number 6. How do you deduce that two vectors are perpendicular? This you can see in the page number 53. So again 53, this point you can write. Page number 53, point number 7. If two vectors A vector and B vector are perpendicular to each other, then their scalar product A dot B is equal to 0, because cos 90 degree equal to 0. Then the vectors A and B are said to be mutually orthogonal. So this is the best answer. You can write For the short answer, question number 6, how do you deduce that the two vectors are perpendicular? Question number 7, define displacement and distance. You can see in the page number 60. So here it is the distance and displacement definition in page number 60. Distance is the actual path length traveled by the object. You can see these two definition in page number 60. So note it down. Question number 7. Now define velocity and the speed. Actually, here in this question it is not saying about the angular average velocity and average speed. It just given velocity and the speed. So you can know the definition for velocity. You all know that the definition for velocity and the speed. Velocity definition is what? Rate of change of displacement, and the speed definition, you know, rate of change of distance, or you can write speed is actual distance traveled by the time. Then you can use the formula. Then you can write velocity is a vector quantity, speed is a scalar quantity. So you can just note it down. This. Question number 8. Like question number 7, define acceleration. They are just asking acceleration. They are not asking about the average acceleration. The definition for average velocity, average speed, average acceleration, everything in the page number 66, 67 and all you can go through. This is just about the just they are asking about the velocity, speed, and the question number 9 is acceleration. We know the definition, rate of change of velocity is equal to v minus u by t, we will write. So unit also, you know, meter per second square. Just note down this. And the next question is question number 10. What is the difference between velocity and average velocity? So in page number 66 you can see the definition for average velocity, and velocity you can use the same definition before I showed you. This average velocity here, page number 66, top you can see it is defined as the ratio of the displacement vector to the corresponding time interval. V average is equal to delta r vector divided by delta t, and here this is one difference. The direction of the average velocity is in the direction of the displacement vector. So this direction. So just note it down. This part is short answer question number 10. Now question number 11, define radian. Define a radian it is given. So it means define 1 radian. So in page number 88 definition is there. Define 1 radian. The angle subtended. You see, 1 radian is the angle subtended at the center of a circle by an arc that is equal in length to the radius of the circle. So that is define 1 radian. Next question is define angular displacement and angular velocity. So in page number 89, angular displacement definition and its formula, theta is equal to s by r, s is equal to r theta. Angular velocity definition and its formula. So in page number 89 you can note it down. Next question is question number 13. What is non-uniform circular motion? In page number 91 it is non-uniform circular motion. So here you can see page number, here if the velocity changes in page number 91 top you can see, if the velocity changes in both speed and direction during the circular motion, we get a non-uniform circular motion. So that is short answer question number 13. Next question is write down the kinematic equation for angular motion. So you can note it down, the page number 94. This red color table, these 4 equation You have to write. This is short answer question number 14. And the last question in, write down the expression for angle made by the resultant acceleration and the radius vector in the non-uniform circular motion. In page number 93 you can see this answer. Here in page number 93, these two expression, okay, so learn these two expression. This is what the answer for short answer question number 15. Next is detailed answer. First question is, explain in detail the triangle of addition. So in page number 47 and 48, page number 47 and 48, here it is starting triangular of addition. So start from here, then you can write all these things. Okay, here I marked already. So the same thing you can use. You have to draw this diagram. It is very important diagram, and this thing. Okay, so up to here, long answer question number 1 in page number 47 and 48. Question number 2 is, discuss the properties of scalar and vector product. So in page number 53, 56 and 57 you can see. So properties of scalar product in page number 53. Then properties of vector product in page number 56 and 57. So note it down. You know that while seeing the page number you will understand more. Next question is kinematic equation of motion for constant acceleration in page number 76 and 77. So equation of motion, equation of uniformly accelerated motion by calculus method in page number 76 and 77. Up to these 4 equation, so derive that. Page number 76 and 77, question number, long answer question number 3. Next question is question number 4, derive an equation of motion for a particle falling vertically, projected vertically in page number 77, 78 and 80. You can see 77 starting from here. Equation of motion under gravity, starting case 1, a body falling from a height h, then this derivation, then 78 up to here, up to equation 2.19, then starting in the next page 80, page number 80, second case, here body thrown vertically upwards up to equation 2.22. that is long answer question number 4. Long answer question number 5, derive the equation of motion range and the maximum height reached by the particle thrown on oblique. So that is in page number 84, 85, 86. So you can see this projectile under an angular projection. So this is what long answer question number 5. So you can see here maximum height, parabola equation, time of flight, horizontal range. So up to equation 2.34 you can mark, that is long answer question number 5. Now question number 6, derive the expression for centripetal acceleration in page number 91 and 92. Here centripetal acceleration, long answer 6. You can see in page number 91 and 92. Okay, so that expression. And question number 7, derive the expression for total acceleration in the non-uniform circular motion. That is in the page number 92. Here non-uniform circular motion, you can just go through that. And these are the questions, book back questions you have to learn inside. And my dear students, you mark all the questions what I shown now. and you can we will discuss this in today's interactive section through Zoom app. So the time you can ask your doubt, and when you're coming to the Zoom app class, it is very important you have to come with proper uniform, and you have to come with a combed hair, and dress neatly, and sit with a nice background, and do not roam here and there while taking the Zoom app class, and follow all the instruction given by the management, and ask your doubt during this interactive session through Zoom app class, and shortly we will see through live class, and thank you all. Bye bye.